Welcome to the Nucleus podcast. This week we're talking about factory-built nuclear. AMPERA's claimed first full-scale, three-dimensional printed reactor module, a wave of small modular reactor headlines in the United States and United Kingdom, and the increasingly obvious pull of artificial intelligence data centers on the nuclear market.
And the AMPERA story is the cleanest place to start because it has the drama of a big claim and the discipline of a very important caveat. AMPERA says it has completed production of the first full-scale, three-dimensional printed nuclear reactor module, including the reactor core and pressure vessel. But that is a manufacturing milestone. It is not, in this week's coverage, an operating reactor or a licensed power plant.
That distinction feels like the whole story, because the phrase first full-scale, three-dimensional printed nuclear reactor module sounds enormous. It sounds like something has leapt from concept into reality. But what actually happened this week was an unveiling on the 1st of July at AMPERA's Innovation Center in Palm Beach Gardens, Florida, attended by more than 100 people, including local officials, business leaders, and employees.
Exactly. Founder and Chief Executive Officer Brian Matthews put it in very ambitious terms. He said, "This next-generation nuclear core and pressure vessel sets the foundation for factory-built, mass-produced nuclear energy." He also said the advanced technology and additive manufacturing demonstrate a clear commercial path for new nuclear technology coming to market faster. That is the commercial thesis. Build in factories, standardize, repeat, deploy.
So let's unpack what AMPERA says it has built, without pretending we can verify the engineering from press release style coverage. The company describes itself as developing the world's first subcritical, solid-state, factory-built thorium nuclear reactor. It talks about a spherical monolithic gyroid core, silicon carbide three-dimensional printing, tri-structural isotropic thorium kernel fuel, and a core-for-life design.
And the reported performance claims are eye-catching. Up to 30 years without refueling, projected output of up to 30 megawatts electric, with larger configurations planned. AMPERA also says safety comes from the core design and physics characteristics, reducing reliance on active systems and operator intervention. But again, the safety language is AMPERA's own claim. The AMPERA coverage does not include independent technical validation or regulator commentary.
I'm glad you said that because subcritical and solid state are doing a lot of work rhetorically. They imply something different from conventional nuclear. But the AMPERA story doesn't give enough technical detail to assess what those terms mean operationally. So the responsible phrasing is AMPERA says, not AMPERA has solved.
Yes. In commercial terms, I'd separate four things. 1. A physical module has reportedly been produced and unveiled. 2. The company has a reactor concept. 3. It has a market narrative around artificial intelligence data centers, defense, industrial users, and maritime applications. 4. It still has to show regulatory status, operating data, customer commitments, project sites, financing, and deployment dates. The fourth category is where bankability lives.
That market narrative is fascinating, though. AMPERA is explicitly aiming at power-hungry customers. AI data centers are central to the company's pitch. Defense and maritime users also make sense in the company's framing because they value reliability and modularity. But the AMPERA story this week doesn't name a customer, a first site, or an actual delivery timetable.
Which is why the power now, nuclear next strategy matters. AMPERA says it has an integrated energy architecture using waste heat recovery and conventional fueled generation now, while creating a pathway to its future nuclear configuration. The point AMPERA is making is that those modular gas-powered systems are 2/3 common with the planned nuclear configuration and use proprietary supercritical carbon dioxide technology. It is a bridge strategy. Power now, nuclear later.
That almost sounds like a recognition that the nuclear part may take longer than the market wants. If, as AMPERA is suggesting, artificial intelligence infrastructure needs power urgently, then a company saying, "We can give you conventional power now and nuclear next," is addressing a timing problem as much as a technology problem.
That is a fair commercial reading. It also helps explain why AMPERA is attaching its pitch to data center demand. Nuclear has the promise, in the company's framing, of dependable power, but this week's AMPERA story is still about manufacturing, not commissioning or operation. So the commercial challenge is to align AMPERA's ambitious, near-term deployment language with the absence, in the supplied reporting, of a customer, project site, or deployment date. AMPERA's pitch is that manufacturing and modularity can compress that cycle. The evidence for that compression is not yet in this week's AMPERA story.
The United States headlines this week had that broader feel too. Power magazine had the AMPERA story, but also the headline, Deployable Energies Unity, Nuclear Reactor Achieves Criticality at INL, third under DOE Nuclear Push. Then there was the Washington Examiner headline about nuclear developers hitting President Trump's July 4th deadline as a third reactor hits a key milestone.
Those headlines matter because they show the mood: milestones, deadlines, criticality, market rebuilding. Orrick's piece was literally framed as Beyond Criticality, how the US nuclear market is being rebuilt. Even without going beyond the headline, that tells you the conversation is not only scientific, it is institutional and commercial. Who can move from laboratory milestones to a deliverable fleet? Who can finance, license, and repeat?
And then the TVA story. It clears a huge hurdle in the race to build America's first small nuclear reactor. Again, the word hurdle is doing useful work. It implies progress, but also reminds listeners that there are more hurdles. Nuclear stories often arrive as triumphal announcements, but the pathway is cumulative and highly conditional.
Quite. In law and commerce, a huge hurdle is not the same as completion. It can be an advance, but the next questions remain. What approval has actually been achieved? What remains outstanding? What obligations have been assumed? And who is taking construction, licensing, and off-take risk? The week's headlines suggest momentum, but they do not suggest that execution risk has disappeared.
The United Kingdom had its own big number story. SGE, based in Poland, is reported to be targeting a 4.2 gigawatt small modular reactor fleet across 3 sites in the United Kingdom by 2034. Multiple headlines put the ambition at 14 reactors and £35 billion.
That is a very different sort of story from AMPERA. AMPERA is a manufacturing breakthrough claim around a module. The SGE story is a fleet ambition, scale, sites, capital, and deadline. 4.2 gigawatts, 3 sites, 14 reactors, £35 billion by 2034. Those figures create political and commercial gravity, but they also invite scrutiny. Site control, consenting, grid connection, supply chain, reactor selection, and finance all become central.
World Nuclear News described an SGE-led team targeting 14 BWRX-300 small modular reactors in the United Kingdom. The Guardian, The Times, The Telegraph, and others all picked up versions of the story. That breadth of attention suggests the United Kingdom press sees small modular reactors as a mainstream energy and investment story now, not a niche engineering subplot.
Yes, and the tone differs by outlet, but the shared theme is ambition. A Polish energy player, a United Kingdom fleet, a large capital number, and a timeline within the next decade. That makes it politically legible. But as with AMPERA, listeners should distinguish plan from project. A plan can be significant, especially if it attracts partners and policy attention, but a plan is not yet an operational fleet.
Then there's the equity market side. MarketBeat had small modular reactors spark a chain reaction for nanonuclear. Zacks asked whether rising demand from artificial intelligence and data centers can benefit nanonuclear. Nasdaq asked whether nanonuclear energy stock is a millionaire maker. AOL carried a headline saying a nuclear energy stock has plunged 32%, and another saying X energy stock collapsed 19.2% this week.
That cluster tells you sentiment is active, but not one way. Investors are clearly looking at nuclear through the artificial intelligence power demand lens, and that creates excitement around small modular reactor names. But the stock headlines also show volatility and skepticism. A market can love the theme and still punish individual names, especially where timelines, licensing, and revenue are uncertain.
I think that's the episode in miniature. The theme is hot, the claims are bolder, but the gap between story and deployment is still the thing to watch. AMPERA's 30 megawatts electric, 30-year core-for-life language is compelling. SGE's 4.2 gigawatts and £35 billion are compelling, but both sit inside a sector where announced and delivered are very different words.
And that is not cynicism, it is just the grammar of nuclear development. Milestones matter. Manufacturing a full-scale module, if that is what AMPERA has done, is not trivial. Criticality milestones matter, fleet plans matter. But commercial reality comes from the next layer: regulatory progress, independent validation, supply chain proof, customer commitments, financing and operating evidence.
One final note, the week also had nuclear-adjacent headlines that pull in the other direction, including the report that 64 United States sailors were sickened after a malfunction involving a backup diesel generator aboard the ballistic missile submarine USS Nebraska. It is not connected to AMPERA or small modular reactors, but it is a reminder that public perception of nuclear and nuclear-adjacent systems is never shaped by innovation stories alone.
That's right. The industry sells reliability, safety, and strategic necessity, but the news environment is broader and messier. A breakthrough headline can sit alongside an incident headline. For developers, that means communications cannot rely on excitement alone. They need evidence, process, and trust.
So, takeaways. First, AMPERA's claimed 3D printed reactor module is a notable manufacturing story, not proof of a working reactor. Second, artificial intelligence data centers are now central to how nuclear companies are positioning themselves. Third, United Kingdom's small modular reactor ambitions are scaling up in headline terms, especially around SGE's proposed fleet. And fourth, investor attention is high, but the market is not treating every nuclear name as a guaranteed winner.
And on sentiment, the news tone this week is promotional and milestone-heavy, while market sentiment is more uneven because the investment headlines include both enthusiasm and sharp share price falls. With artificial intelligence power demand repeatedly appearing in the framing, the nuclear narrative feels especially data center-centric. I'd call the overall sentiment mixed. Thanks for listening. See you in the next one.